Boa noite. Boa noite, pessoal. Só um minutinho de atenção, eu tenho 2 recados para dar. O primeiro é que a partir de amanhã a gente vai começar a vender o churrasco da SEA, que acontece nesse sábado. E também a venda dos kits antigos. Estava lá exposto no Salão Primavera, tem caneca, camiseta antigo. E se você quiser adquirir, é só passar lá para comprar a partir de amanhã. Na parte da tarde, a gente vai vender inscrição para o desafio aeronáutico, o 13º desafio aeronáutico, que está bem legal esse ano e promete bastante. Bom, agora eu deixo vocês com o Diego Bernal. Espero que vocês tenham uma ótima palestra. Boa noite.
Muito obrigado. Boa noite. Como estão vocês hoje? Penso que jantaram querem dormir, eu não sei. Mas espero que vocês despertem. Desculpa se meu português não é muito bom. Eu estou procurando de falar no português, mas eu vou falar em inglês mais tarde. Mas eu vou ver como vai. Ok. Eu vou falar um pouquinho de mim primeiro. Talvez alguns de vocês sabem. Eu sou colombiano, eu nasci na Colômbia. Mas quando eu tinha a mesma idade de vocês, 22, eu morei para Nova York, para ir à universidade, para ir à escola de engenharia. Eu estudei engenharia mecânica. Nesse momento, quando eu troquei, hice toda uma transferência de meus créditos e todos esses processos. Eu terminei minha engenharia mecânica com menções. Abriu muitas portas mais tarde. Depois, eu estava trabalhando com a universidade onde eu estudei. E comecei a trabalhar depois em uma empresa que se chama Cummins Power Generation. Eles se conhecem por os motores diesel, os motores e os caminhões grandes. Eu estava trabalhando em pesquisa, product development, para geradores de potência. É uma coisa totalmente diferente à aeronáutica. Neste momento, eu recebi meu carta da Boeing. Você quer trabalhar com nós como engenheiro estrutural e de payloads? Eu não pensei 2 vezes, eu fui para lá. Mudei de Nova York para Minneapolis, para Seattle. E comecei a trabalhar na Boeing no ano 2006. 9 anos atrás. Depois de trabalhar como engenheiro estrutural e de payloads, minha primeira atividade foi o desenho, fazer um desenho de arquitetura interior para um 777. Nesse momento, várias aerolíneas, especialmente de Ásia, do Médio Oriente, eles têm muito dinheiro e querem fazer coisas muito diferentes em primeira classe. Esse foi meu projeto. Tudo bastante interessante. Depois eu estava pensando, eu quero fazer algo diferente. Eu mudei de Interiors Engineering to Flight Test, to ensaios em voo. E meu primeiro projeto foi o processo de certificação do 747-8 Freighter, ou de carga. Foi um programa que para mim foi eu não sei se para programa tem o mesmo significado ou não. Uma curva de aprendizagem muito inclinada, porque eu não sabia nada de ensaios em voo. Eu era engenheiro mecânico, era tudo novo. Mas eu tive a coragem de dizer, eu vou aprender isto. E foi a pessoa que hizo toda a asignação dos transdutores e sensores para o programa de teste do 747. Esse homem que não sabia nada de transdutores e sensores, terminou fazendo toda essa asignação de 400 transdutores sensores, sabe? Ok, eu posso fazer. Eu nunca falei, eu não posso. Eu posso, eu vou aprender. Eu penso que essa é a atitude que você tem que fazer. A mesma coisa que eu estou fazendo agora. Eu não sei falar português, mas eu vou a procurar. Quantas pessoas de vocês falam inglês? Sim. E você que gostaria que eu falara em inglês, que é a língua que eu falo todos os dias, ou poderia falar em meu broken português de aqui em adelante. Mas vamos a mirar. Também falo espanhol, mas se vocês têm uma pergunta, vocês podem perguntar em espanhol, inglês ou em português. Se não entendo, buscamos uma solução. So, depois do 747 Freighter, eu mudei para o 747 Intercontinental, que é essa versão de passageiros do 747. Depois disso, eu troquei para fazer o desenho de instalações de instrumentação que foram utilizadas para o programa do tanque, que é baseado no 767. E depois fiz desenho para o 787 e para o 787-9. Depois de isso, voltei a fazer parte da tripulação de ensaios em voo com o 787-9 e com o meu último projeto, 757 Eco-Demonstrator. Foi um projeto que estávamos fazendo com a NASA. Eu terminei isso 3 semanas atrás. So, now que vocês sabem um pouco de mim, eu penso que isso sempre é bom, que vocês sepam quem é essa pessoa que está falando. É um parecido? Não sei. Ok, obrigado. Ok, so de ordem do dia, para hoje, eu vou começar a falar de uma visão geral de flight test. Depois eu vou falar do propósito de flight test, dos planos, dos processos e das pessoas. Depois eu vou falar de exemplos de experimentos e testes que fazemos em voo. So, primeiro, vou falar de coisas gerais que fazemos em todos os programas de certificação. Depois, eu vou falar de alguns testes na certificação da propulsão. E depois, eu vou falar de alguns testes que são parte da pesquisa, Research and Development. E depois, eu vou terminar com os vídeos. Ok. So, qual é o propósito de flight test? So, é a validação e a verificação que as características operacionais do avião desculpe, I think I'm going to switch. So basically, we're going to look if the airplane comply with all of the requirements that were put by the designers. So basically, we're validating and verifying that everything that was stipulated is met. Also, we're trying to demonstrate the design intent of each one of the systems. So if you were designing a hydraulic system for 2,000 PSI, you want to see that hydraulic system is reaching those values. So what values is it reaching? Am I designing the right thing? Did I use the right pumps, or what did I use? The other one is we're trying to ensure that the airplane is reliable. So you want to see that the airplane that you're going to be using to go back to, in my case, to Seattle, is going to be, I'll be able to fly on it and I'll be safe. Something that is very important about about testing is that you want to find any issue, any problem with the airplane. Yeah, because what would happen if you build an airplane and you weren't able to find any problem and then you find it later. Sometimes it happens because sometimes it's the nature of engineering. Sometimes you're not able to see some mistake or something that happened during the design, but the idea is to be able to catch it. And if you are able to cut it, you'll be working on a redesign of it. And the last one that I got is, okay, performing research and development, which is something that is not for certification purpose, but you will see it if you can incorporate it in the future. That's the case of the 757 eco demonstrator that we wanted to test some technologies and see if they were viable to be used in 5 years or 10 years or somewhere in the future. And then comply with regulatory agencies. So in the case of the US, it's the FAA, Federal Aviation Regulations. And actually, the FAA have something that is called advisory circulars. In the case of flight tests, there is one, I'll let you know later, but it's AC 257C. So what is important about it is that this one contains all of the guides that they recommend for flight test evaluation of transport category airplanes. So basically, all of the passenger airplanes. So after, in 1 week, you say, oh, I remember Diego was talking about some document that contains all of these things that are performed in an airplane. You just go and Google it, AC27-7C, and you'll find it. I did it, so I know that is there. Also, there is another document that is called, so are you guys familiar with the FAR? So Federal Aviation Regulations. So there is one part that is part 25, and basically that one contains all of the information that is for airworthiness standards for transport airplanes. Okay, so let's go to the next one. So how do we plan flight tests? Usually people have the concept that, oh, flight test is done at the end of the program when the airplane is finished, and they are just gonna go and fly, and that's flight testing. But in reality, that's not the case. So let's say that several years ago, when the 787 was launched, they decided, okay, we wanna build an airplane with these characteristics that is gonna perform like this. Flight test has to come and say, hey, hold on, don't forget about me. Maybe you will see me all the way at the end, but remember, I need to do some design of all of the instrumentations and sensors that I'll be using later on to gather that data. Because how am I going to validate it? Or maybe you're working on a design of a flap or a landing gear, and when they design it, there is no way for you to put a sensor or a transducer. They need to know that you need to be able to work in a design that is going to be in a certain area. Well, at least you can tell them, I need this space of 5 centimeters by 10 centimeters, or can you reserve that space? Remember, I need to get some piece of equipment that I want to install in that area. So at the same time that the airplane program is working on the design of the airplane, on the flight test side, we're working on the design of the test and also on the instrumentation that will be used. So let's say, I'm trying to make a division. Let's say that each line is a year, kind of. And let's say that on the 3rd year, per se, we're going to start working on the design of the instrumentation itself. Yeah. But also, beforehand, there is some negotiation that goes between flight tests and the programs. Even though we are the same company, we have different budgets. And in real life, everything is in terms of money. So they have to decide how much money is going to be allocated for your project. And you're going to say, hey, hold on, flight test, maybe you're not going to see in a production airplane in many years, but this is money that you have to put up in front of your project, because otherwise, without us, you're not going to be able to test that airplane or validate it and put it in the assembly line. So the plane goes into final assembly, and then a year later, it depends on the program, it goes into flight test itself. And then at the end of the entire execution is when the FAA says, okay, you comply with this, with all of these regulations, so now you can go and put it into mass production and you guys can deliver this airplane. Something that sometimes happens is that, let's say in this case, Boeing starts in parallel to the flight test program, they start building the airplanes. Yeah, but they cannot deliver any airplane, but they need to save time because there are customers that need those airplanes. So at the end, if they discover any issue, it's like, oh, well, what am I going to do? They need to rework and redesign or scrap whatever was built. But it's normal in the industry, yeah. But also, usually that doesn't happen. I haven't seen like big things, yeah. But they start working on those terms. And usually, maybe the guy this morning didn't cover that part, but usually, let's say in the case of Boeing or Embraer or Airbus, it is not like a car that you build 10 of them, 100 of them, and then you sell them. No. You sell them first, and then you tell them, okay, I'm going to deliver those to you in 5 years, 2 years. So you put your order, and then they'll tell you like how many years you have to wait. So we have planning, design and build, and then execution. So processes, I think, how many of you, I don't know what years are you at, third year, second year, but when you work usually when you're at a school, you don't give that much importance to your processes, or you don't give the values, like, oh, I don't need to work in a document. Oh, I don't need to work this. This is not for an engineer. Yeah. Later on, you will see that your life is going to be full of documents because you need to show other people what you did. Yeah. It's something that I'm glad that someone early in my life told me, Diego, everything that you write, always think that you're going to teach someone what you did. And that's the best document that you can make. If you're writing something in such a way that whoever is going to read it is going to learn what you did. And not just, oh, I just need to put this value because they want to see this value. Yeah. Then you will see at the end that you start going up. Yeah, because people know your work. And it's like, your work ethics comes from the things you do. And people are going to notice it. So first, we have all of the requirements. So those requirements usually come from the FAA or from each one of the design groups at Boeing. So let's say if you work in flight controls or if you work in the hydraulic system that moves the elevators on the horizontal stabilizer, you're going to say, okay, hold on, guys. I need to make sure that my hydraulic system reaches these pressure values and these conditions. And they are going to tell you, they are going to do a document. Oh, I need to measure pressure number 2, hydraulic system 2, that goes to the elevator on the right side, per se. Yeah, that's going to be written. And then they come to you, this is what I want you guys to measure. And you're going to say, why do you want to measure that? Yeah, and there is a negotiation because every measurement that each one of the design groups creates, it means money because it means entire design to capture that specific data and then do the signal conditioning, all of the wiring, and all of the data system. So then it's convoluted, the process. So once all of the design groups had defined all of these requirements, it comes flight test planning. And it's another game. And you'll be talking to the planners, but also to each one of the people that own each one of the areas and how you're going to build them. Yeah. So let's say, oh, am I going to work on the instrumentation of the left wing first and then on the right wing? Or am I getting parts from Japan? When are they coming? Can I work on them at what point? And there is also, in the final assembly line, there is a process. So you need to work with that process in which they install, in which they build like the nose of the airplane, then they build the tail. So you need to follow those sequences just to make sure that you are in sync. So we got test scheduling. The airplane configuration is, okay. What happens when you go into an airplane and everyone is sitting on the back of the airplane? Or everyone is sitting on the front of the airplane? Yeah, so there are different configurations that you need to keep in mind. What things you need to test in the future? Later, I'm going to talk about how we handle the center of gravity of the airplane during different tests. Huh? We do that one as well. I'll show you that one later. And then, after we work how the configuration of the airplane is going to be handled, we go into the testing of the airplane. That basically is something you do every single day for 7 days, the entire year. And then it's like, oh my God, am I going to have a life? And then you go to the data analysis and approval. So you need to collect this data. And the same night, you'll have another people from your team looking at this data and saying, okay, the results that we got are what we're expecting or not. We're seeing some values that disagree with what we predicted, so we need to repeat this, or we need to redo this, or, oh, let's go ahead and continue the next phase. So there are several things that happen, but it's something that you're seeing every single day. So usually, in the way that I see it, when people think about flight tests, they want to say, why don't you work as a production line, that you do this, and I say, no. We're basically a flying lab, a laboratory that is on the air, and we cannot decide. There are things that you just get out of your hands, and you need to see the data. And who works on that? So I defined it before. You have the FAA, you got Boeing, you got the people from engineering analysis, you got the guys from test operations. So basically, we're divided test operations, test instrumentation, and ground operations. Yeah, and we're working every single day, and each one of us has a specific task. So let's say I'm instrumentation. So I'll be in charge of all of the data system that is going to capture the data. So all the way from having the design of the transducer that is capturing some value, taking that signal and doing the signal conditioning and doing the process of those values into engineering values. Because usually, I don't know how many of you knows what a strain gauge is. No. So let me ask you, has any one of you taken a class in, how do you guys call it? Like materials, where you do some tests in which you take a probe and then you stretch it and you want to see the deformation. You remember those little things? Those are called strain gauges. And basically what you're getting is just some change in voltage that is produced by the change of resistance. But when you see a signal that is just a change in voltage, it's like, what am I going to do with this? So every single strain gauge has to be calibrated. And there are specific parts of the airplane that you want to do a specific calibration. Because you want to see, let's say that you have let me put something that I've seen. So you have a link that connects one of the flaps to the leading edge. That's in the case of the 747. They have something that is called Kruger flaps that go in the front. And you want to see what values of deformation or loads you have on that link. So sometimes you need to take that link and take the entire link to the lab, so the people in the lab can do the calibration and say, okay, guys, so if you get to see this voltage, the equivalent of this is 1 pound or 2 pounds or whatever. For every single transducer that you get, you have a specific calibration. So sometimes you can say, oh, I'm going to go to the store and I'm going to buy 2 accelerometers, and they are the same. But in reality, even though they look the same, the calibration curve for each one of them is different. So you need to keep track of all of this information, even though, because sometimes people can say, oh, let me take these 2, they are the same, I'm going to install them. And you just, hold on, you can't do that, because each one has a specific calibration, and you need to, and all of your signal conditioning is designed for each one of the measurements. So that's something that happens. Everything that I'm going to talk is going to be more focused on instrumentation, since it's my area of knowledge. Yeah. And so that's in the case of strain gauges. Let's say that you got flow meters or pressure transducers. Yeah, that basically a pressure transducer. I don't know if you guys have a class in which you learn how a transducer or a sensor is built inside. But when you have a pressure transducer, basically it is a membrane that has some strain gauges inside. And when you have some pressure going through, you're going to see this layer, this membrane, moving. And when it's moving, it is stretching somehow the strain gauge, and that's producing a voltage change because of the change of the resistance value, and it's going to have the same process. So if you guys had a chance of learning strain gauges, that's going to become the base for many of the transducers, just to understand how things work. And then you have the people from industrial engineering, which are going to be working on the planning and how everything is going to be performed inside of the big complexity of flight tests. So they are going to be assigning the schedules when things are going to be, the sequences in which things are going to be made. And then, of course, we have the people from maintenance and manufacturing. I'm not sure how things are handled here in Brazil, but in our case, as engineer, you cannot go and take it apart and move it, because we have something that are unions, syndicats. No. There are specific tasks that each person has to perform, and this person's job is to do that, and you cannot cross the line because you'll be violating some things. But it's something that these guys are pros at doing, and you'll get to learn so many things from them. Okay, so interesting. So who flies in the airplane when doing testing? Each company has a different philosophy of who's going to be on a test airplane. But in our case, we have, this is something that I found from the University of Texas, that I said, okay, this is pretty cool. So if you look in the forward area, you have the pilots. So the pilots are going to be in the cockpit, of course. And then you got the test director. So who's the test director? This is the person that is going to, let's think of an orchestra. And you got the guy that is telling everyone what to do. And this person is going to be, so we're going to be talking to this guy, and this guy is going to be the point of contact between us that are on the back of the airplane and the pilots. And he has a flight test plan that is going to describe, okay, the first condition that we're going to do is to take off with 20 degrees of flaps, or there is a sequence, and you just go do this. And then once that is complete, you say, okay, we got this one. Now we need to do a wind-up turn. Okay, we got this one. We need to be 5 seconds for, oh, we're going to do a stall. We're going to drop 2,000 feet. And you're on the back. Yeah. So this guy is the person that is going to be working on the planning for every single day. And then on the back of the aircraft, we have a flight test analysis and some of the design engineers. In this case, is the people. So between flight tests and each one of the groups that work on the design of the airplane. So let's say you did that design of the hydraulic system that goes for the elevator. That's my design, so I work on it. I want to see how it performs. So your group, maybe you or somebody else from the same team, is going to get invited to the flight, and that person is going to be looking at that data. But also you have some person from flight test that is going to be providing that data to this person. And it's a teamwork. Everything is interconnected, yeah? Because who knows the airplane? The person who did the design. But also you need a second set of eyes of another person that is seeing the same data and is giving another opinion, yeah? And then on the back of the airplane, we have what we know as ground operations, that basically you need to fly everywhere. So you need ground operations, I think is operaciones en terra. So they'll be working with each. So let's say that we're going to go to Iceland because we need to do some crosswind testing. And who's going to be all of this talking with the people on the ground in that new airport? They are going to be coordinating that. Or maybe we're staying in this. Boeing Field is the name of our, let's say, airport. It is not an airport, but let's say that it's our base. And they are going to be doing all of the configuration changes of the airplane and are going to provide in the airplane with whatever is needed for that specific test. So let's say that you have a test in which they need to load pallets with some weight. Yeah. Pallets creo que pense como uma pequena caixa com certo carga, peso. Okay. As instrumentation. So what do we do during the flight? Some people say, oh, you guys don't do anything. Like, no. Basically, we're going to be looking at the, since we are responsible for every single signal that goes to the airplane, I mean, that goes to the, not to the airplane, to the data system for flight tests, we need to see if there is noise. Sometimes maybe you guys have taken any electronics class, since I think you should, or there is a class in signal analysis, and you'll see, sometimes you expect to see this line, and then you see this line that is like, hold on, what is happening? But then you have to go and track that signal and see, did I do my ground correctly? Because sometimes many of the problems are ground related because you didn't ground it, or maybe you got a ground loop, or maybe simply some connector that was going somewhere got mispinned. And it's the easiest solution, but trying to identify that that's the problem, it takes you forever. Yeah. So this is basically who flies on a plane. So let me go to the next one. So maybe you'll be thinking how a flight test airplane looks, how does it look inside? Everyone is like, oh, Diego, so do you guys have all of these nice seats and everything finished? And I'm like, no, actually, I wish to have a nice chair to sit down. So you guys see here racks, armarios, that are full of instrumentation and pieces of equipment for data acquisition or multiplexing, or some devices that you need to do some specific type of analysis. So let me go here. This one, you can see, hold on. Maybe I changed a lot. My name is Diego Bernal. I'm a flight test instrumentation engineer for the 747-8 program. We're in our instrumentation. I got some hair at that time. Intercontinental version of
the program. This airplane is a computer lab. It's a flying lab. We have over 200 transducers. Transducers basically are sensors that allow us to capture different types of measurements. Each one of the racks have a dedicated function. If I look at the first one, this rack, this one is going to be used to look at inertial data. This rack is used for our weights engineers and our flight operation people. In this rack, we can control the center of gravity of the airplane.
That's not the device to control the center of gravity. It was next to it, but
that is where we are controlling and looking at all of the data and all of the health of the system. We have a specialized rack only to look at the performance of the engines. We have these strip chart recorders that allow us to print data in real time, just for us to look what is happening and how the airplane is behaving, or what is happening with each one of the measurements. So our main goal in instrumentation is to have all of the information saved to be analyzed.
that means.
Is to have all of the information saved to be.
So if you see this image, you can see each one of the workstations and where we sit. So it is not that comfy, but it does its job. So you have different tracks, different racks, different workstations, and all of us, we're sitting in each one of them, and we all have access to all of the data. And if we have a protocol in the way that we communicate to each other, because at the same time, you have to listen to every single control tower in which you are going to. And sometimes the control towers don't have any clue about what we're doing. I actually remember once, it was interesting. We were trying to chase turbulence because we needed to do some testing inside of turbulence. And the guy from the control tower, he got like, what are you guys doing? Where are you guys going? You guys are going to an area with a whole bunch of turbulence. You shouldn't go there. So then they have to go and say, hey, no, hold on, that's what we need. Like, what's going on? Why do you need turbulence? No. So then you have to talk to them so they know what we were doing. Also, sometimes you go to some areas, and usually people haven't seen this airplane because it's a new model. Hold on, is that the 747? Is that the 787? Yeah. Or something that was funny. A couple of months ago, with the project that we were doing with NASA, we went to Louisiana because we needed to get bugs, insects. We were on the news because we are going to Louisiana to get bugs, and we were flying for 8 hours per day, taking pictures, and doing a whole bunch of stuff. And they were, hold on, are you guys the bug catchers? Because the news was, our project was on the news, but we couldn't say what we were doing, but they only mentioned, oh, this is these guys are here because this area is an area that has a whole bunch of bugs. And used to hear people comments, or people from the control towers. Sometimes it's just funny. Okay, so let's go back. Eu quero fazer uma pergunta primeiro. Eu sei que há pessoas que não falam inglês. Se você tem alguma pergunta, eu gostaria de escutar neste momento antes de continuar.
Do you usually do bird crash tests?
Só está perguntando com que frequência tomamos passarinhos, tiramos o avião. Actually, okay. Eu vou falar em espanhol. Cada modelo de avião, ao começo do teste, tem que passar por essa prova, porque você tem que mirar se janela de frente, não, windshield, pode resistir ao impacto de passarinho. Só a prova, se você vai a YouTube, você pode encontrar umas provas em que elas tomam uns frangos congelados, tem como um sistema, como uma pistola, na coxa pneumática, e tiram os frangos congelados para mirar a resistência do windshield da janela de frente ante esse impacto. Quando você, em realidade, quando você vai a um voo, algumas vezes hemos tenido que parar, porque há impactos que você diz, oh, Deus santo, o que passou aqui? ou em algum momento, o piloto liga para nós ou fala, eu acabei de ver some blood, sangue, não, sim, sangue em meu janela. Tá. Oops, how big was? Quão grande foi isso? Empezamos a falar disso. Também quando voltamos à Terra, pensamos a mirar que se há alguma haveria algum problema com esse impacto. Sim. Mas é muito interessante. Algumas vezes você tem que fazer mantenimento em uma área do avião devido a um impacto de um passarinho. Alguma vez eu vi horroroso, eu vi como contamos como 20 passarinhos que passaram a uma melhor vida. Okay, so let me go to this one.
And how do you clean the engine before and after?
Okay, so actually when there is a bird strike, that's the word that we use. So actually the mechanics are the ones that are the masters to do this job. But if it goes into the engine, we have to call a specialized team that is going to look at. They have some sort of equipment to see how bad was the impact of the airplane. Usually you don't find maybe it was cooked. Yeah, but you will see something on the outer side. But you need to do some analysis with some cameras and try to go and look at and look if there is any defect. If there is any defect, you know that there is something that is called fatiga dos materiais. E você tem que mirar que efeito isso pode ter em seu turbina ou motor. Sim. Mas o procedimento de como limpiar, eu não sei. Especificamente, não sei. Outra pergunta? Ok, so agora eu vou começar a falar dos testes. Vou começar a falar dos testes que fazemos na certificação e depois falo de alguns de propulsão. Okay. One test that is very important is called flutter. So, how many of you have taken this class, equações diferenciais? Ok. E vocês lembram uma solução que tem que fazer para, penso que era de segundo grau, segunda ordem. E usualmente os livros têm um exemplo. Esse exemplo é de um ponte que começa a vibrar. O que passa é que a interação do ar, like the airflow, com a estrutura do avião, vai criar certas excitações. Eu não sei se é a mesma palavra. Não. Eu estava pensando. A ideia é que eu tenho que buscar, pesquisar as frequências naturais da minha estrutura. Porque se meu avião está funcionando, eu vou a uma frequência natural, is gonna, let me show you a video. This, okay. Okay. Oops. Let's try to see what happens. Ok, hay un video que foi feito por NASA, e são par de experimentos. Ok. So, estes experimentos, eles têm diferentes exemplos. Um é do ponte, outro vídeo é de partes do avião no túnel de vento. Ok. Ok. Here it comes. Ok, esperamos que isto. Mas vocês têm que ver a importância de algo que eu quero que aprendam, essa importância das frequências naturais em qualquer estrutura. Porque se você está fazendo um desenho, algumas vezes olvidamos o de análise. Do análise de frequências. Porque muitas... Falemos que eu não estou fazendo um desenho em um avião, mas eu estou fazendo um desenho de qualquer coisa. Eu tenho que fazer, que instalar um sensor. Quando você mira as especificações do sensor, você vê uma frequência da frequência natural do sensor. E você tem que estar seguro, você tem que ter certeza que esse sensor que você está selecionando vai trabalhar com a estrutura ou com a machine que você está desenhando. Sim. O que passou? Espera um segundo, eu vou fazer uma coisa mais rápida. Ok. Mientras eu busco que isto funcione, alguma outra pergunta?
Quando se ingresa los testes, ¿cuándo, qué momento se hace los ADs, SBs, solamente después del teste totalmente aprobado, o durante la producción del teste, a ingreso de service bulletin?
Espera, alguém sabe o que é ADs, CBs? Eu não sei o que é.
Creio que não. Solamente um, sabe?
Eu não sei o que é a palavra.
Service
Okay.
bulletin.
Okay. So there is a group that is há grupo dentro da companhia que faz todos os service bulletins para todos os aviões. E quando achamos alguma situação ou a aerolínea encontra que eles estão passando por alguma situação e alguma solução, a companhia manda este boletim para todas as aerolíneas que têm este modelo, este tipo de avião. Sim. Mas é grupo de Boeing que... Há grupo que se chama Service on Ground, e também like Fleet Engineering, and so estes grupos, quando um avião tem problema, vão para o lugar do problema, começam a analisar e depois buscam uma solução para este problema, e o Service Bulletin é distribuído. Okay. So, penso que vou voltar a isto em um momento. Ok. Há teste bem importante. Okay, it is called takeoff performance. Basically, when you're doing a design of the airplane, you have it, it is ready, but you need to see what are the characteristics of each one of the parameters during takeoff. Decollage, olvidé uno. So you're going to look at all of the acceleration parameters, like how fast it's going to be able to go from stop to the moment in which we take off. Which one are the minimum lift-off speeds? Like, ¿qué velocidade você tem que ter para que o avião poda voar? Algo que chamamos rotation rates. Quando você vai okay. When you see that the airplane is gonna lift, always pay attention to the elevators. There is a moment in which they move the elevator, and it's the time in which the airplane is gonna take off. But what happens when the pilot do at some certain moment that is not the moment, that is not the right time? Yeah. So there are a whole bunch of tests that need to be performed to determine these parameters. And then these values that we get are the values that are going to be posted on the flight manual. So every airplane is going to have a flight manual at the end, and it's going to tell the pilots, okay, these are the parameters. If you want to be able to take off this airplane, you need to have this speed. And when you reach this speed, you're going to be able to pull the elevator, and you're going to be able to take off. But also there is other testing that is going to prove what would happen if the pilot doesn't do it at the right time. So we need to prove to the FAA, okay, if there are these variations because we're humans and the pilot is going to do it maybe before or after, what is going to happen? So that's part of the takeoff performance. Also, something that we call abuse takeoff. I have my help here. Okay, so let's say the pilot pulled the airplane and it was too fast. We need to see what is happening with the airplane as a whole. Yeah, did I do it too fast? Why? And you need to look at every single component of why did it happen, or did it have a signal that was right on time? But the idea is to get all of this data for the pilots, or any pilot that doesn't have the same skill level can do it. Yeah, it's part of the training that each one of the pilots must have. And the engine out testing. So what would happen if you're about to take off and one of the engines fail? Yeah. So I'm gonna go to another example. How many of you do kayaking? Eu penso que é uma pergunta para as pessoas que moram no Rio, perto da água. So I do kayaking sometimes, or when you're in a boat and you're paddling, usually when you paddle, you always do it one side, the other side, or one side, or you have two people doing it simultaneously. What happens when you do it only on one side? Yeah. So the same thing is going to happen with the airplane. Yeah. So let's do it this way. Let's say that this is the body of the airplane, and these are my wings. If I have thrust in both sides and I lose one of them, what is going to happen? My airplane is gonna try to rotate like this. But how can I contrarrest the effect of losing this engine? Yeah. So there is something that is called rudder. And you have to take that rudder and move it in such a way that it is going to contrarrest the lack of thrust from one of the engines. And pilots should be able to know how to do it and should be able to do it. But also, we have to test the airplane to prove the world that you can do it. Yeah. So if you lose one engine and you need to take off, you still can take off. At the end, every single thing that happens is a pilot's decision. The pilot will decide, okay, am I going to take off, or am I going to reject the takeoff? Yeah. So that's what happened with this abuse takeoff and engine. Something that was very interesting, the first one that I have, 1 million pounds takeoff, I was on that test. And for us, it was very special because it was the 747. But the idea of having a load of 1 million pounds inside the airplanes and seeing this airplane taking off, it is like, we were always like, okay, it is flying. And when you see it, it takes some time because you need to get that trust on the engines in such a way that my lift forces are going to be higher than the weight of the airplane. So maybe it's going to take a longer runway in order to be able to do the takeoff. Yeah, so that one was pretty cool. The other one that I got here is the brake testing. So every airplane has to have brakes. And can you imagine what would happen if you land and you wouldn't have them? So since we have, so let's say that sometimes when you buy an airplane, you have different brake manufacturers, Ducati and others. And sometimes when you buy it, you can say, oh, I want this brand name for the brakes, oh, I want this. But also, we need to test those brakes and see how they perform. So what happens here? So we're gonna see what's the maximum energy that the brakes can take when I do takeoff. I mean, when I reject the takeoff. And I'm gonna do it at the maximum load that the airplane can handle. There are some regulations that tell you, okay, you have to have some conditions in which the weight of the airplane has to have these. And that's part of the requirements that are established by the FAA or also by Boeing as a company. And this one is pretty cool to be on this one because the logistics are crazy. Because you need to talk to all of the firemen, so the firemen, the fire trucks, and all of these people come because they need to extinguish the fire. And why do they have to extinguish the fire? Because basically you have this airplane about to take off with all of this load, and suddenly it has to pull the brakes, and it needs to stop. But since I'm having it with the maximum thrust and the maximum load, you're gonna see the brakes toast. And it has to reach a certain level of temperature, and you'll see how the tires deflate. Yeah, hopefully this video works. Oh, parece que sí.
There's few jobs as rewarding as those in bone test and evaluation. And getting a chance to test a brand new airplane.
Esperemos un poquinho. Actually, this one was my before I did the 757, this one was my program. And it's exciting because what do you guys think that I need in terms of location to be able to do this? Yeah, so there are two locations that usually we go to for this type of test. And usually what you want is a huge and long runway, because you need to be sure that when the airplane is going to stop, you're still going to have a runway. And I remember, so have you guys heard of some place that is called Roswell, New Mexico? Usually everyone knows because of UFOs, ovnis, extraterrestres. Yeah. Essa área onde as pessoas falavam deste projeto é tudo um mito, mas quando você vai este poblado, todo o turismo é basado nos ovnis. Muito engraçado. Quero fazer 2 minutos. Eu quero cerrar a ventana de internet, a minha apresentação é começar de novo. Okay, so I went back to the flutter one. So I want you to pay attention to this one. It doesn't have a voice, but it's cool to see what happens. So those are the effects of flutter on a bridge and a punch. Você não quer encontrar isso em um avião. Quando começa a vibrar, é uma loucura. Você não quer ver isso. Então, Flutter é o único ensaio de voo que nós não estamos no avião.
As rewarding as those in own test and evaluation. And getting a chance to test a brand new airplane just might be the pinnacle. Such is the case with the new Boeing 787-9 Dreamliner. And with any new airplane, Boeing must demonstrate that even when fully loaded, the airplane can safely stop the takeoff on short notice.
To certify the airplane, we make sure that the airplane can stop on the runway at its highest takeoff weight and its maximum speed.
It seems very unlikely this would ever happen. However, it is a requirement that we test this, and that's what we do. We test very extreme situations that we really expect to never encounter.
Those extremes include not only loading the plane to its maximum weight and accelerating to maximum speed, but installing brakes that are 99% warm.
We grind the brakes down to the thinnest that they can ever be. We deactivate one of the brakes to simulate that there's a failure. So, I mean, we go to extreme lengths to make sure that the test is the absolute possible worst case scenario.
It's a scenario that takes some intense planning.
90% preparation and 10% execution.
A very coordinated effort with test engineers, pilots, emergency crews, and airport personnel, to name just a few.
We've been doing landing performance and high-speed rejected takeoff performance for probably a month prior to actually conducting this endpoint, which is that maximum energy condition.
Then, the moment of truth.
Bring the engines up. You notice that the airplane accelerates very slowly because it's very, very heavy.
Accelerate the airplane again to about 188 knots of ground speed.
And then once you get to the takeoff speed, you slam on the brakes.
The 787-9 makes a complete and safe stop. Now, it's crucial to monitor the energy
So você pode ver o fogo
that is
lá.
created from the force placed on the critically worn brakes. To simulate real-time emergency response, fire crews must wait 5 minutes before engaging with the airplane.
We are monitoring the wheels, the tires themselves deflate per design. They have devices called fuse plugs within the wheels themselves that melt under high temperature and then in a very controlled fashion release the pressure of the air, of the nitrogen in the tire so they don't blow treads. We want to make sure that that occurs in a very controlled fashion.
From stopping distance to temperature to fail-safes, Boeing test and evaluation makes sure everything goes safely, exactly according to plan.
From a performance perspective, it was right on.
It's disturbingly unexciting.
And brings the 787-9, one step closer to the flying public.
A locação deste teste foi, você escutou de Edwards Air Force Base, em Califórnia, um deserto. Sim. Se eu não lembro, penso que esse tem o mais longe pista os Estados Unidos. Não estou seguro, mas penso que se não é a mais longe, é a segunda. Não lembro bem. Mas você precisa, você não quer ver nenhuma coisa passar. Okay, so I have another test that is called the wave vortex test. So anyone have heard about this test before? So let's say, okay. Okay, how many of you, no one does kayaking, so I cannot go to that example. But if you're in a big boat, and you're in a small boat on the back, usually you see this big boat having this wave on the water, and as a small boat, you're like, yeah, same thing happens on the air, kind of, in a similar way. So you have this big airplane. You can be in another airplane just right behind it, because you got the wings and because of aerodynamic characteristics, when the airplane takes off, you're going to generate swirls on the wingtips. And what happened with those swirls? Você está criando uma turbulência que depois vai debilitando. Se você vai detrás do avião, você tem que ter um espaço muito longe desse avião a meu avião. Do contrário, eu vou estar na turbulência que é generada por esse avião. Sim. So there is testing that is done, that is performed for that. In the case, can you imagine the A380 or the 747? Those are big airplanes. So there is testing in which there's different testing, but let's say that we need to take another airplane that is going to be on the back, and we need to see what effects this airplane has by being behind this airplane. Yeah. How my other airplane is going to be influenced by this turbulence. Yeah. So they are testing, and basically, if you're traveling on a A380, you need to be at least 8 nautical miles behind that airplane if you don't want to feel the effects of this turbulence that is being created by this airplane. Or if you are in a 747, it is 6 nautical miles. So since the A380 is bigger, it needs some safety, some margin of safety. You don't want to be there. And also, okay, this is another testing. This is before way at the beginning of the program. And we call it the max wind loading test. So, eu volto ao meu exemplo de quando você faz uma prova de materiais. E você você está estirando meu probeta, e de repente rompe, snap, yeah? A mesma coisa tem que passar com um avião, sim. Nesta prova vamos a poner, okay, we are going to generate some loading conditions on the airplane, and we're going to see at what point the wings are going to snap, are going to break. So there is a regulation by the FAA that it says that the airplane has to withstand at least a 150% of the maximum loading of the airplane. But in these cases, it has to do with other norms, other standards that define which one are the design loading conditions for an airplane. So you have to have like 6G in one direction, 3G or 4G in other direction. Yeah. but this testing is based on those loading conditions. And I'm gonna go to another test while it loads. So we have that one for the static test, we call it. That's an event because everyone wants to see when that is gonna break. And also there is one that is called the fatigue test. So basically you're trying to simulate, let's do
Though
this.
it's strapped inside a metal cage, this 7887 Dreamliner is about to taxi out to the runway for its first flight. By conducting this takeoff, Boeing engineers
Esperemos un poquito. So basically, they are going to try to simulate the conditions that an airplane goes through its life cycle. So they're going to be simulating takeoffs, landings. But it's a static. It is put in a test bed, and everything is going to be performed by loads that are going to be controlled automatically, simulating whatever the airplane is going to experience on the air. But this thing it is not a test that happens just in one day. It's a test that happens in 3 years. So this fatigue test is going to be set up, and we look at it every single day, and we try to see how many cycles this airplane has. Usually in an airplane, we call a cycle every time that the airplane takes off. Okay. Let's see.
start fatigue testing of the 787, a long and grueling process that puts the plane through more than 100,000 simulated flights.
Essentially what we're trying to do is match the damage that an air.
Se você está usando a internet inalámbrico daqui, yeah. But this is being able to see the structure that has to be created just to do this testing. It is another piece of engineering. Yeah. Every single test that we do is an entire team designing the test, and I think it is what is cool about being in flight test. Usually I tease my other friends that work in the production side of airplane, and I say, your job is boring, I don't want to do that. Sim, eu não quero fazer isso porque é muito aborrecido. Eu gosto da dinâmica, eu gosto do câmbio. Mas trabalho que todo mundo quer estar nesse grupo, mas você tem que sacrificar também muito. Se eles falam com você, vamos a viajar por 3 semanas. Ok, você pensa que são 3 semanas, mas de repente, 2 meses. Eu lembro uma vez, eu ia por um mês, terminei 6 meses morando num hotel. Então, Deus santo. Ok. Ok, depois miramos este. Okay, so let's continue. So there is another test that is called the velocity minimum unstake. This one is very interesting because if you look at the on the back of this airplane, if you see it here, you see that the airplane is touching the runway, but it is not that it's really. Okay, so let's say that we have this sign. It is like a piece of wood, madera, that we install on the aft side of the airplane. And what is going to happen is, what I want to test is which one is the minimum speed for the airplane to take off. Yeah. See the one is the minimum speed, and which one is the shortest runway, because you need to be able to tell, okay, this airplane is going to be able to take off at this distance. And what happened is that they have so they reach the speed in which they think the airplane is going to take off. It is not just a test. This test is like hundreds of these things. Yeah. And when you are doing them, some days, like, I don't want to do another test. I don't want to do another test. I want to finish. Because it is in your body, it's exhausting. Like, the only thing that you want to do at the end is you just want to go to sleep. So by moving my elevators, I'm getting my airplane ready to take off. But then when it reaches that maximum speed, and you see that the lift that is created is equal to my weight, you see the airplane lift. And that's what I want to see. Also, we have other testing in which we want to see the effects of water in a runway. So I just want to make sure. The first one is a splash test, in which I want to make sure that if I'm in a runway that has water on it, that water, when it splashes on the engines, nothing is going to happen. I don't want to see my engines fail because of the splash of water. And also, I want to see the reaction of my plane as a whole, because just imagine when you're in a car and the road is wet. Your car is going to slide or do something, or you need to make sure that your brakes are working fine. So the same type of testing is something that we do to see the performance of the airplane in these different conditions. My favorite one is crosswinds. Yeah. So have you guys ever seen a video when you have a strong crosswinds and the airplane cannot land straight, but it has to go some sort of sideways to be able to land? Yeah. So there is a regulation that established that an airplane has to be able to land in a field, in a runway, in which the crosswind speed is higher than 20 knots. And yeah, so this test is interesting. Yeah, so you say, oh, I just need a wind that has a speed higher than 20 knots. Try to get that wind with that speed. So usually the target speed is 40 knots, and you go and land. Usually we take it like we start watching different areas around the US and see what areas by meteorology are gonna have these speeds on the air. Sometimes you don't find it, but there is a place that we always find it, and it's called Iceland, Islandia. And this one, I have some pictures that I took because I was traveling around while I was there. And actually, I could just throw myself to the wind, and the wind was able to hold me. It is interesting. It's an interesting place. But it is not something that is constant. So we have to put a station on the ground that is measuring the wind speed every second. Yeah. And you need to have some values that are constant, because suddenly the air is 25 knots and you're happy. Oh, 25, we're gonna start. Suddenly it drops 10 knots. What it means is that you're gonna be inside this airplane waiting for the wind to speed up and have something constant that at least give you a minute, 2 minutes to do the takeoff. Or if you are if you're flying and you're testing the landing, you're in contact with the people that is on the ground measuring the wind speed and saying, and you're listening, okay, we got this value, land now, you have 20 seconds, and then you go. Sometimes like, oh, oops, the wind speed went down. We need to repeat it, and it goes on and on. Also, there is something that we call, it is the cold day testing or cold soak. So just imagine that here in Brazil, we don't have those low temperatures, but if we're gonna sell an airplane to Russia and the airplane is gonna be going to Siberia, you need to make sure that the airplane is gonna work fine. And by having the airplane overnight there, that all of the systems of the airplane are gonna work, and the engines are not gonna get frozen and not be able to rotate or perform. So that's something that we do there. Let's see. Are you getting bored? Is it okay? Okay. So another testing, we call it community noise. And what we do on this one, there is another location, forget the name, but I think it's in Montana, and in which no one lives there. And we need it because we need to install microphones in a big area just to see the effects of the airplane in terms of noise, ruido. Yeah, so we just need to make sure that we are complying with other regulations in terms of noise. Another one, we call it functional reliability. And it is a test in which we want to see the airplane in real life conditions in a busy airport and how the airport crews are going to be able to handle the airplane. Yeah. So if you know, with the case of the A380, it was kind of complicated because they created this big airplane, but no airports have these type of terminals that could handle this airplane. Yeah. In the case of the new 747, we didn't have this problem because we were using existing terminals. So for us, it's easier because we don't have to tell the airports, hey guys, you need to build a new terminal for me because you guys don't have the space. So I think those are considerations that we always keep in mind when we try to sell airplanes, because not every city has the money to build a new terminal only for me to be able to land. Okay, and I have another test. Let me go through a couple of those that I think are interesting. Okay, flight load survey, I'm gonna mention that later. That's one of my favorite tests that I ever been on. Just that, and I've seen people puke, vomit. And I'll explain you why. Okay, the second one is gauntlet test. So before the airplane is being flown by the first time, we have a van, un carro, in which I can generate all of the signals for all of the buses inside the airplane, and also it can generate pressures, like you connect something to the pitot tube, and it's gonna make the airplane believe that it's under that pressure to simulate that altitude. And there are all of the signals, you try to recreate them on the ground, and you wanna see how each one of the systems are going to perform. Yeah. So by having the pitot tube, and you're putting into the pitot tube this amount of pressure, you're making believe the airplane that, oh, I'm 3,000 feet, I'm 5,000 feet, 10,000, whatever altitude. And I want to see the response of my airplane. And also, I want to see, I'm putting another bus signals on the airplane. I'm going to say, okay, so what you're seeing is this, where you're seeing that everything is simulated by using the airplane, all of the buses. So I think this is one of the tests that is just done before the airplane is actually just right before flying for the first time. All of this testing is made to the first airplanes of a model. So yeah, no, it is not performing every single airplane. I don't know if this one is, but everything that I'm talking about is for only new models that go into certification. We go Autolance. This is the test that I dislike. Eu não gosto desse teste, eu não quero estar nesse teste. Why? Just imagine when you are trying to, so let's say that you're the person that is doing the programming, the engineer, for doing the auto landing. And at first, you know that you need to recreate some sort of equation, and usually everything is sinusoidal, and you have to do a whole bunch of iterations of that software. So if I'm in the first set of iterations of that software, I'll be sitting on the airplane, and you'll be feeling this thing. And do that for 30 times. Go, take off, land, take off, land. It's the only test that it makes me sick. Yeah. And among ourselves, if there is a new person that is working, everyone is like, I want to see if this person is going to puke. See? Yeah. Mas quando fazemos este teste, eu sou a primeira pessoa, eu não faço. Eu trabalho no meu escritório hoje, não quero. Okay, stall warning, stall characteristics, and stall speed. So I think everyone knows what a stall is. Yeah. So basically, there is a term that is used in aeronautics, and is the airplane envelope. And when you see the airplane envelope, there is a minimum speed that you need in order to keep lift, so the airplane can fly. And the difference could be the same, it could be different when the altitude of the airplane changes. So this graph that you develop based on the minimum speed that the airplane needs, and I forgot what I was going to say. And the altitude, it is called the airplane envelope. So if you're on the airplane and you're doing, just imagine when you're in a lab and try to gather every single point. In this case, to gather every single point to recreate that curve, it means a section of time. And you're sitting down, and you're looking at all of the accelerometer values. You're making sure that the vibrations of the airplane are fine, that it's not going to certain values. And suddenly, you're sitting down. In the way that we say it, we're all strapped, so we don't go somewhere else. And then you go and you hear, okay, so everything is communicated. Okay, 3, 2, 1, blah, blah, blah. And you're like, and you fall 2,000 feet. And then they recover the airplane. But we want to make sure, there are different things that we test. So one is recovering the airplane from a stall. The other one is the warning signals that the pilot gets when the airplane is about to stall. So there is a noise, barulho. It's like, it's annoying. It's like, so once you hear that, okay, we're going to fall now. Yeah, so that's for stall warnings. Stall characteristics is to define how the airplane, what is happening to the airplane during stall and how it is going to recover. And the other one that I don't get it here, but is the stall speeds, and is looking for those minimum speed that the airplane has to have at every single altitude. Let me see, what do I go here? Smoke testing. So we just try to put it this way. When you go to a club, a discoteca, no sé, you see those smoke generators. Something similar we use on the, I don't think it is the same, but we use different techniques to create smoke. And we just need to make sure, we need to test that all of the fire alarms, fire detection systems, and everything is going to work. And also make sure that this smoke is not going to go into different places. We want to see what is happening when this is happening. Noise testing, I think this is what I got. So I'm going to skip some of the videos, and and at the end we try to just play them all. Propulsion certifications. Let me just go to this one. This is the heart of the airplane. Basically, if you don't have engines, you're not going to have an airplane. You're not going to be able to fly. So engine in flight start. So you're going to put an airplane, you're going to shut it down, and you're going to see what is going to happen when you try to start up the engine when you are flying. And also, you need to be able to test that the airplane is going to be able to fly with one engine. Negative gravity. This is the video that I'll show you. It's my favorite one. So what happened with negative gravities? Yeah. So have you ever guys been on? Usually that doesn't happen. But if you go into an elevator, and the elevator goes too fast, you're like, yeah. It's a state in which you're going to be able to float, basically, because in the way in which you go down is higher than the speed of gravity. Yeah. And how do we accomplish that? Changing the pitch of the airplane. So you're going to go up, and then you're going to go down. You're going to go. I'll show you the video. That one is it is more interesting. But you're going to experience values of negative G's. Values, usually the intent is, there are some testing that goes between 0G and 2Gs, and the other one in which we see negative Gs. Okay, so why do we do this? We just need to make sure and prove out to the world that if we go into these conditions, the engines are going to be able to withstand them. And they continue to operate safely. Also, this is part of something that is called flight load survey, and you try to go to crazy loading conditions on the airplane, and just to test that the airframe of the airplane is able to withstand those.
Just putting away the carry-on bags won't be
Actually, I was inside this airplane when this happens. Eu estava dentro, mas eu estava a céu a parede.
You don't have to come down, things fly in the air, it'll literally go straight up to the ceiling. And if you come down and hit you on the head.
You see, this is no ordinary flight. The new Boeing 747-8 freighter is taking off to perform a flight load survey. It's one of the most grueling flight tests for an airplane and for those on board. A strong stomach comes in handy. You will understand why in 3, 2, 1.
It feels like a roller coaster. So you go up, you go down. It's a challenge to keep yourself strapped in, your computer, your notes, and make sure that you're watching the right thing.
It might look like fun, but it's serious business. Flight load survey is designed to validate the structural capability of the airplane by putting extraordinary stress on the fuselage and wings. To do so, the test pilots perform extreme maneuvers, such as repeatedly pitching the airplane down and then pulling up, going from 0 gravity to 2 times gravity in seconds.
It is as much as you want to push in airplanes. I mean, some of the test points are up to 2.5 Gs, and in service, that's very close to what the overstress limit of the airplane would be.
Going to 2 times the force of gravity greatly increases the load on the 747-8, which is already flying at its maximum takeoff weight of nearly 1 million pounds.
As you start putting stress on the airplane, you'll see the wings will start bending up, and they're under tremendous stress.
Really what we're trying to do is take it to the outer corners of the design envelope and demonstrate that the airplane can withstand the flight maneuvers and at the gross weights that we designed it to.
In the cabin, the flight test engineers and structural analysts are trying to stay in their seat while monitoring the airplane's performance. These roller coaster flights can last 4 to 5 hours and are not for the faint of heart.
Because they can finish it so quickly, right? You kind of don't have time to, oh yeah, that was great. You got to concentrate what you're doing, right? Get ready for the next one.
A grueling test to make sure the new Boeing 747-8 freighter can handle loads far beyond what it will face once in service.
Airplane handled great, easy to fly, well behaved, and just did a great job.
So, você gosta de roller coasters? Pense que você tem que fazer isso por 5 horas. Sim. Quando você termina, você não quer fazer nada. Sua cabeça está como... Você camina, mas você não sabe o que está fazendo. Sim. Mas... ter a oportunidade de estar dentro desta prova é única, porque só se faz uma vez por modelo de avião. Há coisas que você tem que fazer algumas vezes para fazer gravidades negativas, mas não é algo que passa frequentemente. Mas sempre que eu lembro isto, sempre penso que foi interessante. Temos que ter muitas plastic bags, sacos de plástico, em caso de necessidade. And also another test, it is called the engine fuel suction fit test. And what would happen if the pump, if the electricity that feeds the pump that fuels the fuel to go into the engine fails? Oops. We need to be able, the engine by design is going to be able to pull the fuel and to continue working. It is something that, and we need to test that that's what actually happens. So we need to turn off the pump and see if the engine is actually pulling the fuel and being able to fly like that. So yeah, demonstrator engines continue to operate safely, and why? Because the regulations ask for them. And also this one is high altitude testing. There is something, also we use another term that is called lapse rate takeoffs. Like, cuando você, en los carros antigos, eles tinham um carburador. O problema do carburador era que a diferença, se você ia a uma cidade baixa, uma cidade mais alta, a quantidade de oxígeno que se precisa para a combustão é diferente. Então, com as turbinas é a mesma coisa. Você tem que mirar como as turbinas vão funcionar quando você cambia de altura. Usualmente fazemos este teste em La Paz, Bolívia, porque eles têm um aeroporto que is way up there. Sua altura do aeroporto é mais lá de 13.000 pés de altura. Sim. Quando você chega a La Paz, se alguém ha ficado na Paz, saído na Paz, você não pode respirar. Toma uns dias para que você possa respirar, subir a escala. É horroroso. Sim. Mas você tem que demonstrar que o avião pode funcionar em diferentes cidades, em diferentes alturas, okay, and take off, being able to take off, and we need to study what parameters changes when the altitude changes. Yeah, and actually, usually, sometimes I get taken to this test because I'm one of the few people who speak Spanish in flight tests. So it's like, Diego, you want to come with us? Because the logistics, when you go to a city, something that I always talk to people is how important is to learn another language. Because if we go to La Paz, you go with 90 people who speak English, and then the few of us who speak Spanish. And you need to be able to communicate with the control tower. And there are maneuvers and things that we do that usually when you go to a commercial airport, these guys have no clue what we are doing. Or usually the guys at the control towers, their English is limited to normal operations. Then when you try to tell them something different, they get lost. So one of us has to be inside the control tower with the guys in the control tower to do the communication, because we understand the language from the flight test side, and we are able to talk to these guys what we're trying to accomplish. And also the logistics of being in a different city, and people need to get fees, and all of the immigration and customs, and you get to know every single person on the airport. And if you go to a city, everyone wants to see the airplane. So maybe you're going to have people from the government that wants to see the city. Oh, Boeing is here. So you need to be ready to answer questions, to do tours, and who's the one that is going to do it? Oh, Diego, you're the one who speaks Spanish. You're going to come with us. I'm like, sure, I'll do it. Okay. And I know that we're almost done, but I'm going to do this one pretty short. So the last program is called Eco-Demonstrator, and it's basically a research and development program, like pesquisa and desenvolvimento. Something that is special about this program, that actually is special for Brazil right now, is that Embraer, Boeing, they just signed an agreement on June 30 to work on the next Eco-Demonstrator. So the previous Eco-Demonstrators have been Boeing airplanes, but for the new one, it's going to be an Embraer airplane. And we're going to be working in this partnership. Maybe I'll be here more often. I don't even know if I'll be here or not. But that's the idea. And what we try to do with this type of technologies, we want to validate certain concepts that, let's say that you're doing your PhD, and you come up, oh, I have developed this thing, and I think this is gonna work, and everyone agrees with it. But then you need to actually prove it, and you need to test it. So basically, we prepare an entire airplane in which we're modifying a wing, we are modifying certain parts of the airplane to test this new concept. And maybe it's gonna work, maybe it is not gonna work, we don't know. But that's the idea of doing these research and development programs. But fortunately, it's been a success, and many of those have been proved to be very good. I'm gonna talk about the last one, that is the plane that I work with, that we work with NASA and other people involved on it, like NASA, TUI, that is an airline from England, Stifel Bank, the bank that is in charge of the leasing of the airplane, and AFRA, that is another company that works on recycling the airplane, and other society. So there are technologies that we were working on. It was a design of there were two things. One was a design of an advanced wing to study the laminar flow on the airplane and see how it's going to change. And the other one, it was some coatings that were developed by NASA to reduce insect accretion, just to see how many insects are going to be stick on these panels. Okay, the other one is active flow control. This one, it is a fly stand that is 3D printed, but what is innovative about it is that we were using recycled materials from composite materials. The middle one on the bottom, the one that is energy harvesting electronical dimmable window, is just imagine the concept of having a solar panel, una celda solar, una janela, in the window. And you're trying to capture this energy from the sun, and you want to store it, and then use this energy to be able to dim the window. So something that is proving the 787 is that in the windows, we don't have like the normal curtain. We push a button and it gets dark. We push another one and it clears up. So, but in this case, we're trying to prove a concept in which we're going to get the energy from the sun. And the other one is the airframe recycling. So basically, on the first one, there were different coatings that were provided by NASA, and what happens with this coating. So have you guys seen when you drive and you're on a long drive and suddenly you see all of those insects on the bumper of your car? Same thing happens with the wing of an airplane. Yeah, you're gonna see, that's why we were going to a place with bugs. Because when you have bugs, what is gonna happen with the laminar flow is gonna change. Yeah, so we were trying to look for ways to reduce the accretion of bugs, and we were testing like some of nanotechnologies incorporated in these coatings to reduce that accretion of insects. And also, yeah, and some new design on the leading edge of the airplane. Actually, what is cool about the NASA part of the project, since it is NASA, the results are gonna be available to the public. The Boeing side is kept for us. Okay. Also, this one was a NASA-sponsored project. It is. So we needed to prove another concept in which we have some jet actuators that were some jets like air jets, and we wanted to see the behavior of the loading on this tail when those. No, I forgot how to speak. Okay, so if I have these jets my airflow is going to change. So by changing my airflow on the tail, I want to see how it's going to affect the loading conditions on my rudder. So an implication is if we were able to prove that this technology could be incorporated, it's going to reduce the length, the height of the tail, which is heavy, and usually you have a space constraints in some hangars because you don't have them so tall.
Better crosswind conditions also.
Okay.
Better crosswind conditions also.
Mm-hmm.
Lower area on the tail.
Mm-hmm. And usually the higher stress concentration is going to be on the lower part of the vertical fin. This one was a 3D printed, which we incorporated into the 757, and we were showing that it works, and that we are able to recycle some of the materials. And let's see. Okay, we have 5 minutes. Do you guys want to see another video? Hopefully it works.
When you're testing an all-new airplane, you go on so many flights, work so many weekends, they start to blend together. But for these Boeing pilots and engineers, this Saturday morning is one to remember.
Sábado na manhã.
Finish the last test required to certify the 787 Dreamliner.
Getting to the point where we've worked so hard for so many years to finally get to the point where at the end it's just unbelievable.
Just as the fog rolls in, the team sets off from Everett, Washington to complete function and reliability.
Oh. Espera, eu quero cambiar a qualidade. Okay, so.
On the airplane, you go on so many flights, work so many weekends, they start to blend together. But for these Boeing pilots and engineers, this Saturday morning is one to remember. They're preparing to finish the last test required to certify the 787 Dreamliner.
Getting to the point where we've worked so hard for so many years to finally get to the point where at the end it's just unbelievable.
Just as the fog rolls in, the team sets off from Everett, Washington to complete function and reliability testing, where they'll put the airplane through more airline situations. It should be a breeze compared to what the 787 test fleet has already been through. Boeing put one Dreamliner into a refrigerated hangar to see if it can start up at minus 45 degrees. On the runway, pilots put the tail down on the ground to measure how slowly the 787 can take off. They slammed on the brakes while the jetliner was speeding down the runway to simulate the ultimate projected takeoff. In the air, pilots flew the 787 at the lowest possible speed, then up to almost the speed of sound. They purposely put one Dreamliner through hundreds of stalls to make sure it can recover in such an emergency. In other flights, some of the most extreme loads were placed on the airplane to test for flutter. Upon landing, the 787 had to handle fierce crosswinds, wet runways, or just fly repeated passes to test for ground effects.
This is all done to demonstrate the robustness of the airplane in the event of almost anything that could happen to it. And in every case, the airplane has achieved exactly what we've desired.
The 787 is a revolutionary design with its extensive use of strong but lightweight carbon composites, more electric systems, and advanced aerodynamics. All those features have to pass certification requirements. To date, the 787 test fleet has flown just over 1,700 flights, racked up more than 4,800 flight hours, and performed more than 25,000 test conditions, pretty much everything imaginable.
I'm used to landing the airplane 100,000 pounds overweight. I'm used to flying it with the overspeed warning going off for hours on end. Or flying the airplane with an engine turned off.
After flying around the western U.S. for 6 hours, the team brings the 9th Dreamliner back to Everett. Everything went according to plan. So with the sun now shining, It's time to land and make aviation history.
When the airplane landed, it had with it all the hopes, the dreams, the hard work of the tens of thousands of men and women at Boeing and our partners around the world who have labored so long and so hard on this airplane.
Or 787 Chief Pilot Mike Carriker, who was in the flight deck for the first and this last flight. It's a long journey, worth savoring.
To look at all those features working together seamlessly, and you understand all the work that it took to get there, you're just so proud of the tenaciousness of the team that put it together, and you wish you all could have been there to watch it.
Ok, so se você tem a oportunidade, Boeing has a channel on YouTube. Usualmente, buscamos publicar muitos vídeos de testes e de muitas outras coisas. Vocês podem tomar um tempo e buscar todos os testes. Penso que é interessante. Alguém tem alguma pergunta?
O avião está no ar lá e começa a receber alguma rajada de vento inesperada, várias rajadas de vento, e começa a atingir a frequência natural da asa, por exemplo, e começa a entrar em ressonância. Tem algum mecanismo, algum dispositivo mecânico, algo que o piloto possa fazer no ar para conter essa ressonância e impedir que entre em colisão? Em colisão não, que ele aconteça uma catástrofe, a asa se parta, algo do tipo?
Usually when we do flutter testing, quando fazemos o teste de flutter, as únicas pessoas que estão voando são os pilotos, porque todavia não há uma certificação para que as outras pessoas possam ficar no avião. Se eles encontram flutter, eles diminuem a velocidade do avião e tratam de sair da condição de flutter. Há muitos sinais que estão indicando a eles o que está passando. E também, nesses testes, há algo que se chama telemetria. Todos nós estamos mirando no salão de telemetria o que está passando. E temos imagens de todos os acelerômetros. E fazemos diagramas em tempo real. Se nós vemos que há uma condição que está presente, nós comunicamos com os pilotos para dizer que está passando e que tem eles que fazer. Mas eles têm que cambiar a condição, porque todas estas condições são induzidas, são provocadas. Sim. De nada.
Alô, boa noite. Na verdade, eu acompanhei no processo do Dreamliner, quando ele foi ser entregue no fim do processo, parece que quando ele já estava operando, teve um problema, acho que troubleshooting, algo do tipo, né? E depois precisou ser retirado do mercado para voltar a ser operado até que fosse executada a correção. Quais são os procedimentos que vocês utilizam quando tem esse tipo de problemas, né? E qual a sua função nesse momento? Qual que é seu papel?
Ok. Há várias coisas que passam. Eu pertenço ao grupo de ensaios em voo. Se o avião está no mercado, está funcionando como uma aerolínea, meu trabalho não está lá. Agora outro grupo de pessoas que se chama Airplane on Ground. É um grupo de engenheiros que, quando há uma coisa que passa com um avião, eles voam diretamente a esse aeroporto, ao lugar onde aconteceu. E também há outro grupo que se chama Field Service. Só uma pessoa que trabalha em diferentes localidades. Só esta pessoa faz o primeiro assessment, a primeira assessment. E fala com as pessoas de Airplane on Ground. Eles começam a fazer um estudo para mirar o que está passando. E dependendo das coisas que eles descobrem, começam a dirigir-se a cada um dos grupos que fizeram o desenho desses componentes ou desse sistema. Essa maneira em que funciona. De por si, eu pensei uma vez, eu gostaria de aplicar, trabalhar em um grupo destes que estão viajando a ver os problemas que estão passando com os aviões. Eu penso que você aprende muito mais quando tem que resolver problemas. O que eu gosto muito de instrumentação é que a eletricidade é algo que você não vê, mas você sabe como se comporta. Mas quando você tem que fazer troubleshooting de um sistema, é como um challenge, um reto. É como adrenalina que sube. Eu quero buscar uma solução para isso. Eu penso que é algo que eu gosto. Outra pergunta? Eu espero que vocês desfrutaram da minha apresentação. Eu busco ser um pouco dinâmico, eu não quero ser, não sei. Mas se vocês têm uma pergunta, eu vou ficar aqui toda esta semana. Só falem comigo. Uhum. Eu espero que isto seja algo motivante para que vocês busquem informação. E há muitas coisas que fazer no mundo.
Muito obrigada, Diego Bernal. Foi um prazer receber você aqui no Brasil.
Obrigado.
Espero que seja o primeiro de muitos encontros e muito obrigada por tudo. Quem sabe na próxima SEA a gente se reencontra.
Muito obrigado. Obrigado.